Number 22. We are choosing, this is one of my favorite questions probably. We're choosing three real numbers independently at random from 0 and 1. What's the probability the greatest is greater than 2 times each of the other two numbers? Okay, so we're given here, okay, A is greater than 2B and also A is greater than 2C. So the trick to any of these kind of problems, and we did in fact see this kind of similar trick in number 19, right, or number 18, where we're imposing this kind of ordering, arbitrary ordering, and then multiplying by order at the end. Whenever we have these kind of X, Y, Z kind of cases or geometric probability, we should just impose some ordering. And in this case, okay, it does not necessarily make sense to say, A is greater than or equal to B is greater than or equal to C, but it does make sense to say, okay, which is our largest number, right? Because our whole problem here hinges on the greatest of the numbers being greater than the other two numbers. So let's just say our largest number, let's say our three numbers are A, B, and C. Let's say our largest number was C. Now, could it be A, B? Yes. What we'll do to account for this, multiply by 3 at the end. So let's say we designate C to be the largest, right? Okay, C has to be greater than 2 times each of the other two numbers, meaning that C has to be greater than, not equal to. And in this case, it doesn't really matter because probabilities, these are real numbers. The distinction is basically the same. But let's just say this, right? Or A and B are both less than C over 2. Now, there's actually a really quick shortcut here using integrals. And this is the solution I did. So we have, of course, we have our times 3, right? We have the integral of what's the probability A is less than C over 2? That's C over 2. What's the probability B is less than C over 2? Also C over 2. The probability is just integral of C over 2 squared dc from 0 to 1. Because C can range from 0 to 1. And the probability for each of these values of C is just C over 2 squared. And this is a very simple integral. This just becomes C squared over 4. And this is just C cubed over 12, 0 to 1. And that's just 1 over 12. And we multiply by 3 to get an answer of 1/4. Now here's kind of a visual way to visualize this, because sometimes, figuring out this integral way is not always the easiest. So the same logic still applies, right? We're really focusing on C here. That's kind of the crux of this. So we're trying to visualize this with like 3D, right? 3D, visualize it. So C, let's say C is our entire axis over here, right? So when C is at the very, very top, let's say this is 1, right? 1, 1, 1. When C is at the very, very top, B and C can be at most there, right? Or you know what? We should probably visualize this like, let's just say the opposite. Let's say this is 1, and it might seem strange why I'm doing this, but let's just say this is for the z-axis, or the c-axis, I should say. Let's say this is 1, right? So when C is 1, A and B is less than half. So we can have kind of this, A and B are both have to be less than half. So that means we have kind of this region like that, right? And then, okay, let's say maybe C was instead 1/2. Now we would have, that means A and B have to be less than 1/4, right? So we have something like this instead, kind of like the bottom face, except it's scaled down. And let's say C was 0. There's no possibilities for A and B. We would have this kind of point. And as you can imagine, as you vary A and C, this kind of just varies. So we can kind of extend this out to get a pyramid. Oops, that's not how it's supposed to look. Okay, something like that, okay? And yeah, so this is a pyramid. And the volume of this pyramid is going to give us the exact thing, because imagine we have this whole 1 by 1 by 1 unit cube where we just pick one random point, and we have the a-axis, the b-axis, and the c-axis, like kind of like x, y, and z. So what is the volume of this pyramid? That's just 1/3 base area. That's 1 times the height. That's also 1. Sorry, the base area is not 1. The base area is 1/4, right? Because this is half. So base area times the height, which is 1, giving us 1/12. And then we see the exact same values in integral, multiply by 3 to get 1/4. So yeah, that's kind of like the two ways of thinking about it. One from a purely calculus point of view. And if you're familiar with calculus, I'm sure you find this method like very straightforward as compared to this 3D visualization. But this is also nice and cool to understand how we and use just 3D models and use the volume of a pyramid to get our volume. So yeah, this is a pretty neat problem. I hope you enjoyed this video.